I begin? Okay, let's do some warm up. Okay, let's do some recap first. Yesterday we started with our standard form, right? And I believe everybody still remembered what is the format for standard form. Then after that we went on to simple interest. And we went on to compound interest. Okay? Today I want to do a bit of some simple questions. Let's go back to our standard form as a warm up, okay? I want you to try this question. So in your own notebook or your own foolscap paper, write down this question. Okay, please evaluate this and leave your answer in standard form. Come on, quickly. Waste time, quickly. It shouldn't take you too long. Done? 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 Who needs more time? Raise your hand. Yes, answer in standard form. Sorry? When you, okay, was your answer exact? Is it exact? If it is exact, then there's no need to round off to 3SF. Okay, we round off to 3SF only when the number keeps on going on and on forever and ever. Then we have to stop somewhere, and that's why we have this thing called 3SF. If the answer is exact, it is an exact what? 3.1428. You leave it as that. You only round off if it is exact, right? Okay? So, is this what you got? Is this what you got? Okay, if you got this, can you take a green pen and put a tick? Right now, I want you to try another question. This is the first one, and this is the second one. Yes? No, there shouldn't be a 0, 0 in your calculator. Okay, for this number, right, is 6,750,8700, right? This is not in standard form. What I want is your answer to be in standard form. And when your answer is in standard form, the two zeros over here, they do not matter. They're not significant. Okay? So the two zeros here not required. Okay, now everybody else, I want you to try another question. Okay, try this question. Very similar question, isn't it? Yeah, 10 to the power of 100. Oh, is that a problem? What's the problem? Math error? Who got a math error? You know why you got a math error? Because your calculator is not powerful enough. Well, if you have a very powerful calculator, you'll be able to do this. But But there's only a standard list of calculators that we can use, right? Is it on the board? Okay, we'll bring up the list of calculators that are approved. So, in the exams, what if you get this type of question? And you cannot use your calculator, it doesn't work. What can we do? Use your brain. Oh, who said that? The one in gray, right? Okay, please stand up. Tell us how you use your brain and solve this. Stand up, stand up, stand up. Come on, hurry up. Listen carefully, huh? He's going to teach us how to use our brains. Power take the 102. Take who at? Huh? I don't understand. Wait, I'm asking him. Now, what about the power? Take the bigger one and put where? Here. And then? Okay. 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 But what if you don't have this question? They cannot do? Really? So if I don't give you a question before that, you cannot do this one? Okay, then you tell me how. Okay, the rest of you better be thinking also, because this is likely to come up for exams. Yes, how? You're getting somewhere. Just try a bit more. No, you think about it yourself. Don't listen to him. And stop looking at Xiaolong. Were you trying to factorize? Yes or no? Were you trying to factorize? What did you say? Give up. You give up. No, don't give up. Okay, come. I'll help you. 10 to the power 102. That is correct. Then what goes into the bracket? Over here, I'm trying to factorize. Okay, if you look at, there are two terms in the question, 3.87 times 10 to the power 100 and 6.72 times 10 to the power 102. Which one do you want to work with first for factorizing? Okay, try the first one. So after I factorize, I take out 10 to the power 102, what am I left with? This is what I get for the first term, right? If you okay, everybody, please try. Please take a close look at this. If you multiply this two, will you get this? Will you get it? Is it the same thing? Yes, isn't it? Please convince yourself, they are the same thing. Okay, now, the next part is the easier one. Plus what? 6.72, yes, please sit down. Okay? Understand what's happening so far? Okay, this is just simple factorizing. Earlier on, I had a question, right? It looked quite similar. Let me bring up that previous question and use the example. 3.87 times 10 to the power of 4 plus 6.72 times 10 to the power of 6. This was my original question, wasn't it? So now I'm going to try, instead of simply relying on my calculator, I'm going to factorize out 10 to the power of 6. You have a choice. You can factorize out 10 to the power of 4, 10 to the power of 5, 10 to the power of 6, so on and so forth. But if you are willing to just listen, I am going to always factorize out 10, the one that has a higher power. Okay, in this case, I'll factorize out 10 to the power of 6. So when I factorize 10 to the power of 6 out, from the first term, what am I left with? I will be left with 0.0387. Why is that so? Let me just do a side calculation. If you can use your calculator for this, you will realize that this is actually equals to 1, 0, 2, 3, 4, 5, 6 times 0.0387. Or then this will give you, how much is that? 38700, isn't it? And that will be the same as this, 38700. Okay? Anybody lost at this stage? You must sound out if you're lost. Okay, any more? Okay, so one more time. Please take a look at this part over here. 10 to the power of 6 times 0.0387. 10 to the power of 6 is just 1 million, isn't it? And then 1 million times 0.0387, what do you get? You get 38700. Right? Do you follow this step so far? Okay, 38700. Let's check back to our original first term. Is this value also the same? Yes, they are the same. So what's the point of doing all this first? Let me show you. Just be patient, okay? Now that we established they are the same thing, let us look at the second term. We have 6.72 times 10 to the power of 6. If I factorize out 10 to the power of 6, what am I left with? 6.72. Nothing complicated. This is just basic factorization. Just that I am choosing to factorize out 10 to the power of whatever has a higher power. Between 4 and 6, I take out the higher power. And I will show you why. Okay, so for this step, we established that they are the same thing. They are equal now. Okay, let's continue. This is 10 to the power of 6 times. What is in this bracket? Do we need a calculator for this? We don't need it, but you can use it if you want to. And you will realize that this will be 6.7587, isn't it? Just simple addition inside the brackets. And leaving it in standard form, we will get 6.7587 times 10 to the power of 6, right? And I did this without using a calculator. So why am I making things difficult for myself when all of you managed to solve it at the beginning of the class with your calculator? Why am I making things difficult for you? Because when I threw you the second question over here, when the powers are very big, your calculator could not handle it, but you must be able to handle it. And the strategy for that is to always factorize out the greater power. Okay, so between 10 to the power 100 versus 10 to the power 102, your friend over there in gray, he selected 10 to the power of 102, which was the right choice. Okay, by doing so, let us see what we end up with. Okay, back to this question. And we have 10 to the power 102 multiplied by 6.7587. Put it in our standard form. Okay. So over here we have our answer in standard form already. Any questions? How do I get 0.0387? I just take, because I am trying to factorize out 10 to the power 102, right? And over here, I already have 10 to the power 100. I need to squeeze out another 10 to the power of 2. And how do I do that? I divide this number by 100. Then I will get 0.0387. So that I can factorize out power 102. Okay? Are there any questions? When I first looked at this, I had a question. Why choose to take out power 102? Don't you think it is easier to take out power 100? Do you think it is more convenient to take out power 100? Let's try and see what happens. All done with copying this down? Over on the screen right now, this is what I recommend. But let me try another method. In blue this time, 3.87 times 10 to the power 100 plus 6.72 times 10 to the power 102. Our natural tendency is to try and factorize out 10 to the power 100. Let's see what we are left with, okay? For the first term, after I take out 10 to the power 100, what am I left with? 3.87, very good. What about the second term? If I take out 10 to the power 100, how much? 672. 672. Do you see why? Because 6.72 times 10 to the power of 2, you get 672. Okay, nothing wrong with this so far. I'll still put a, this is still correct, but let us continue. This will give me 675.87 times 10 to the power of 100. Now, is this in standard form? No, right? So I need one more step. And what is the one more step? I need to move my decimal this way, right? Okay? And I will end up with 6.7587 times 10 to the power of 102. Get it? So, I have over here two methods for you to choose from. The first method, in black, will ensure that your final answer is in standard form if you take out the higher power. But it takes a bit of getting used to and practice. Whereas in a second method, in blue color, it is more intuitive because we are taking out the smaller power. But that means you have one more step of calculating or changing it to your standard form. Okay, notice that the answers are both the same. Can? Okay, so far? So, I would like you to try a question from your textbook, question number 4. This is on exercise 1.4. Okay, let's try question 4a together right now. I want you to do it using the factorizing way. Now we're dealing with negative powers. The whole approach does not change. We still take out the bigger power. Between negative 9 and negative 7, which one is bigger? Negative 7 is bigger. Let's take that out. Raise your hands if you need help. Okay, let's take a look. For this question, we again want to factorize out the greater power. So between 10 to the power of negative 9 and 10 to the power of negative 7, the one with the greater power will be 10 to the power of negative 7. Okay, let's factorize that out. 10 to the power of negative 7. Let us look at the first term. 6.8 times 10 to the power of negative 9. For this one, if we factorize out 10 to the power of negative 7, we will be left with just mental sum 0.068. Okay? You can do a check again by yourself. This will give you 6.8 times 10 to the power of negative 9. It is the same thing over here. Same thing. You can check yourself. Next, plus 9. Okay? And finally, we will get 9.068 times 10 to the power of negative 7. Can? Okay, so subsequently, there are other variations for this type of questions. For example, if I give you this question, okay, this is my own question. For those who are done with 4B already, please take a look at this question at the bottom and try it without using a calculator. Try it without using a calculator. Three times 10 to the power negative 5 times 1.6 times 10 to the power 4. Hey, for this question, is there a need to factorize anything out? Are we doing addition or subtraction? We're not. We're just doing multiplication. And don't forget your laws of indices. What do you do when you are multiplying two numbers with the same base but different powers? What do we do with them? Okay, if you those of you who know it already, work on it. Yes, yes, this is 10 to the power 4. All done? Done with the question at the bottom? Right. In this case, it is just multiplication. There's no need to factorize. Class, can I have your attention? All look out on the screen. Okay, we have 3 times 10 to the power negative 5 times 1.6 times 10 to the power 4. So let us group all the similar numbers together. 3 times 1.6. And we just rearrange 10 to the power negative 5 times 10 to the power 4. So 3 times 1.6, you will get 4.8, right? It's 4.8 times 10 to the power negative 5 plus 4. Right? I believe this is your first law of indices. So then you will get 4.8 times 10 to the power of negative 1. This is our answer in standard form. Okay? So again, for this type of question, I can easily use my calculator to find the answer. But in the exams, if I change this to negative 500, and then maybe I change this to 400, then you can't do it again with your calculator. That is why you need to still apply your laws of indices. Okay? So with this, I would like you to add on the homework that was given for 1.4, right? Question 4C to H. Question 4C to H. Practice on this method of solving and evaluating. should have started on your homework yesterday. So I'm just adding 4C to H. I've already done A and B in class just now with you already. Okay? Now let us move on. We will continue with where we left off yesterday, our compound interest. Boy, you sit in front of me, you talk and talk and talk. Okay, let's move on. Yesterday we talked about compound interest formula, and this was our formula. A(n) equals to P 1 plus R over 100 to the power of n. Now, can anybody tell me what does P stand for? What about R over here? Rate? Rate? That's just it. Interest rate per period. Okay, very good. This is very important. What about this one? Number of periods. What about this AN over here? Total amount. This includes principal. Okay? Now, yesterday we stopped at example 20, page 28. Example 20, A and B completed already. Let us move on now to 20C. Okay? So same question, principal equals to 6,700. R equals to 8. Sorry. Interest rate equals to 8% per annum. Okay, and the duration equals to 5 years. We saw how we were able to substitute all these values for part A and part B. Now for C, there is a difference. It is now compounded monthly. So yesterday I asked you, in a year, how many times do you expect the money to be compounded? 12 times. How many periods, how many such periods are there in a year? How many such periods are there in a year? If I compound it monthly, then 1 month will be 1 period. So how many of such periods would there be in a year? 12. Definitely 12. Okay? And accordingly, the interest rate will also be changed. Because over here, question given, interest rate is 8% per annum, right? Then what about interest rate per month? Because right now, 1 period is 1 month in part C of the question. Since 1 period is now 1 month, the interest rate will also be adjusted accordingly. Okay? So P, we have it already. In our formula, we still need the value for R and N. So R being the period, R being the interest rate, how much would that be? It will be 8 divided by 12. Because 8% per year. So in 1 month, it will be 8 divided by 12. Anybody, any questions for this one? 3 Enterprise, any questions for the value for R? No? Okay, so this is, in other words, 8 over 12% per month. Okay, because in this question, 1 month is 1 period. Now, we still need another value, which is the value of N, which is the number of periods. How many periods would that be in 5 years? How many? 60, but don't just tell me 60. Show me your working. How do you get 60? 12 times 5. That will be 60. So what this means is that there are 60 months inside these 5 years. Okay? Now with all these values, I can substitute very easily into my formula. And I'll just get my answer. So therefore, the total amount, AN, will be equals to P, doesn't change, 6,700, 1 plus the value of R, right? Which is 8 over 12 over 100. Okay, then this will be to the power of 60. So if you want, you can put 12 times 5. Or you can just put 60 if you had shown me this earlier on. Oops, sorry. Or you can just put 60 if you had already shown me this in the previous step. Can? So from here, calculate. The total amount will be 9981.97 2 dp. Before you show me the final answer, there should be something with more dp, then you round it off. Okay, like this. Now is this the interest that was earned? No, it is the total amount. And I will say this again and again in my class, and yet during the exams, I will still have students who throw away the 1 mark because you forget that this is not the interest. This actually includes the principal. And unfortunately, students keep forgetting that. Careless. So practice now enough, then you will not forget. So interest earned will be equals to 9981.97 minus away your principal, which is 6,700, and you will get 3281.97. Okay? Okay, here's where you need to try and practice yourself already. Do try it 20. Do try it 20 yourself. All the steps that I given to you for example 20 are also found in your, it tells us that 1 period equals to 1 year. Okay? And then we simply substitute everything into our equation, our formula. AN equals to 8400, 1 plus, and the interest rate will be 9%. Compounded for 6 times. Okay? So this is what we have for AN, and you will get a value. Then you will need to round it off. 2 dp. There is still one more step, because we will still need to find interest. Will be equals to AN minus your principal. Okay? So then that will be your final answer. And I'm not going to spoon feed it to you because the answers are already at the back. Any questions for part A? Straightforward. The slightly more challenging one will be in part B. Okay, compounded monthly. Therefore, 1 period is equals to 1 month. Okay? Since 1 period is not 1 month, let us determine what is the interest rate for our, this is our interest rate per period. How much is the interest rate right now? 9. It was 9% divided by 12, right? Over 12 and then divided by 100. Now, has any of the teachers told you that they do not like to see fractions in a fraction before? See over here, fraction in a fraction is very ugly. Okay? We don't like to see this because it can be confusing. Are you telling me 9 over 12 divided by 100? Or is it 9 divided by 12 over 100? Is there a difference? Yes, there is. So, we avoid writing like this. I can rewrite it in another way. Times 1 over 100. They are the same thing, isn't it? But this is much clearer. Okay? This is my interest rate per period right now. I can do a little bit of simplification. This will be 3 over 400, right? Yeah, correct. And next thing I will need will be my N, which is total number of periods. This will be how many? Placed inside for 6 years, right? So 6 times 12. I will get 72 periods, 72 months. Now with this, straightforward substitution into our formula. AN is now interest 8,400, 1 plus Wait. Okay, this one shouldn't have been here. This is just 3 over 4. Okay, and this is 1 plus 3 over 400 to the power of 72. Okay? So with this, get the value, round it off, and interest will be equals to AN minus 8,400. Get an answer. Okay? So what I should see will be this one. This is our key to getting it correct. Did you have this? Do you have all the correct values? If you do, then good. If you haven't, please go back and watch the video again. You must know how to do this, huh? Any questions so far? Then I'm going to move into something more exciting. Part C. Do you have a part C in your textbook? No, right? Because I'm giving you part C myself. Now it is compounded quarterly. Same question, but now it is compounded quarterly. Do you understand what that means? Okay, you understand what it means by compounded yearly? You understand what it means by compounded monthly? Now if I say it is compounded quarterly, it means 1 year divided into 1 year divided into 4 equal parts. So first quarter, second quarter, third quarter, fourth quarter of the year. Understand what it means now? Yes, you got it right. 1 quarter of the year is basically 3 months. Okay? So please try the same question, but now it is compounded quarterly. How long is 1 period first, okay? So this means 1 period is equals to 1 quarter of the year. Okay? And I know many of you try to find out if 1 quarter of a year, that's actually 3 months. Then you start to get confused between your 3 and your 4 and your 12 and whatever not. But all we need to know is that 1 year is divided into 4 equal parts. Your money will be compounded once over here, another time over here, one more time, and one more time at the end of the year. In 1 year, we will compound it 4 times. Correct? That is 1 year divided into 4 equal parts. That's why we call it a quarter. So in 6 years, how many times are we going to compound it? 6 times 4 lah. Okay? I'm getting ahead of myself. Let me just put down the interest rate first. R, which is our interest rate per period, will be equals to 9, what was it? Originally 9%, right? 9 over divided by 4, because in 1 year we have 9%. Okay? All of this originally 9% per annum. Now I divide it into 4 equal parts. This will be 9 over 4%, 9 over 4%, 9 over 4%, 9 over 4%. Get it? Get it? Okay, so this is my interest rate per period now. Next thing, I need my total number of periods. This will be 4 times 6, which is 24 periods. Okay? With these two information plus my principal, I can now substitute them into my formula. AN is equals to P, which is 8,400 times 1 plus 9 over 4 times 100, or we can call it 9 over 400, or 9 over 4 divided by 100, or 9 over 4%. They're all the same thing. Whatever your preference is, as long as it is mathematically accurate. This is to the power of 24. Okay? Questions, anybody? No? Then, do you think we can come in more types of questions? What is another suitable period that we might give you? Half a year, yes. if it is compounded half a year, what happens? Okay, so you can go and try it out yourself. I'm not going to do that question with you right now, because we are going to move on to one last type of question. We're going to move backwards. Okay, if you look at try it 21. We have always been giving you the principal, the interest rate per annum, the number of years, and then you calculate the interest, right? What about try it 21? We go in the other direction. I need you to manipulate the equation, the formula. Try it now.